Ah. Ah. All right. Let me just edit a few things. Something went wrong. I cannot edit my own video. Why? For whatever reason. I cannot change the title. What do you mean, oops, something went wrong? The fuck is that supposed to mean? Are you serious? Give me a second. Why can't I fucking change the title? Are they retarded? Why? YouTube? Seriously? I can't change the title, so now... Okay. Right now I'm trying to stream, but I can't seem to... Why? The system fucking sucks. Let me fucking change the title. Okay, whatever. Stupid, what the fuck? Alright. Anyway. Linear lab 4, study time for test, whatever. No, okay. I can't seem to change it, so whatever. Instead, what we're gonna do is work on the assignment for networking. So we have the packet tracer assignment. Here, MAC and IP address. Cool. Let's do that one. One gig of memory is dedicated to Google Chrome right now. Nice. Fucking bullshit. Okay. Anyway. Yeah. Blah, 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 blah. Okay. So. Well, I can't seem to change the title, but this is what we got. Alright, so what is this Cisco training thing? Packet tracer identify MAC and IP. Okay. So gather PDU info and reflection questions. Background, blah blah. activity is optimized for viewing PDUs. The devices are already configured. You'll gather PDU information in the simulation mode and answer a series of questions about your data you collect. Go Venus. Alright. Gather PDU. Review the reflection question part 2 before proceeding with part 1 and will give you an idea of the types of info you'll need to gather. Gather PDU info in a packet as packet travels from this to this. Okay. Let's open all this. What does it say? Gather PDU information. Click on 172.16.31. Oh, one sec. Where's that? That 31.2. Okay. Then from there, what must I do? Says to enter ping 10.10.10.3. Okay, so ping 10.10.10.3. Okay. Quest timed out. Oh. I lost one somehow. Okay. Switch to simulation mode and repeat the ping command. A PDU appears next to that. Simulation mode. Oh, where's that? Switch to simulation mode and repeat. What? What the fuck? What did he do? 1 second. Hold on, guys. I'll be right back. Okay.
In detail with time-controlled direct simulation environment.
Let's see what he says.
This tutorial covers some basic features of the simulation environment. The default mode is real-time. Here, the time is continuously running as indicated by the clock. Click the Simulation tab to switch to the simulation mode.
Oh, okay. Makes sense to me. Okay. Switch to simulation mode and repeat the ping. Oh, it's a blue envelope. Click the PDU and note the following info from the outbound PDU layer. Jesus Christ. Save that. Okay. Destination MAC address. Destination. I don't understand why it opens as two fucking things. It's stupid. Why? Okay. So click 17 destination MAC. Source MAC. Source address. CRC. SRC. Destination address. Source address. So it's this one. Source IP. Destination IP. And at device. At device. Am I retarded? Data type. That's not here. The hell? Am I not seeing that? Alright, whatever. Click capture forward to move PDU to next device. Okay. Then it says from here, whatever. Click capture forward to move PDU to the next device. Gather the same info from step 1. Repeat this process until PDU reaches its destination. At device, destination, circ. Whatever. Capture forward. Goes to the hub. Destination address. That ultimately change. Alright, just close all my windows. Damn it. Hello, cat. Did this address change? No, it didn't. Preamble's the same. Source address is the same. IP is all the same. Okay. Whatever. Next. From the hub, it's sent to. From here, if we look at this. it's looking for this address, which, what I can tell, is this one. No. Destination MAC is this. Huh. What exactly is this telling me? Okay, so the frame is sent to the hub, which is sent to two systems. This system, with this computer, which has nothing, which does not accept it because it is not the right IP, but the switch then accepts it. And then from there is sent to the router, which should, oh, this changed. Okay. Uh, so, I mean, if we were to look at the picture, the destination MAC changed when it went to the hub. From there, it went to the switch and then back to the router. And then this is the destination. I'm going to assume this is the last one before the router puts it back to the switch. So if we keep going, destination MAC is now the same. Preamble. Source, that's all the same. Blah. Access point. Blah. This one accepts it because it's the right IP. And this one does not accept it because the IP is wrong. Okay. Part 2, reflection questions. So what's the different types of wires used in this connection? Oh, what the fuck? What's this one? Serial? No, that's fiber, isn't it? That's fiber, that one. The switch, yeah, to the, okay, so. Different types of wire you connect. Answer the following questions regarding the captured data. What were there different types of wires used to connect devices? Using the acquired data. What is it? Does it ask to find Destination MAC, source IP, destination, at device, computer. At device. Hub, switch, router, switch, access point, PC. Destination MAC. Has none. Source MAC. Source IPv4 and destination IPv4. Blah blah blah. Question asks, what were the different types of wires used? In this case, we see over here. Jesus. We have copper straight through. Is this? Yeah. Copper straight through, fiber, and I don't, yeah, fiber. Did the wires change the handling of the PDU in any way? No, it did not change the info. I can't spell. Am I retarded? It's one L. Okay. Good to know. Throughout the network. Did the hub lose any of the information given to it? No. It did not, but it sent it to a host that did not accept the PDU. Assuming I'm getting the word PDU right. Protocol data unit. Physical layer. Okay. What does the hub do with the MAC address and IP addresses? Is that somewhere in my notes? Or is it asking based on what we saw? Seems to not record anything. So, what does the hub do with the MAC? It does not record any of the addresses. Did the wireless access point do anything with the information given to it? It broadcasted. No. broadcast. Did. Where did we write? Where did I write this? Different types of casting. Broadcast. Is this not a freaking word? What is this? Well, hence online the dictionary says it's fine, but it broadcast to both hosts before one of which one of them the destination accepted the frame. To both hosts before one of them the destination accepted the frame. Was any MAC or IP address lost during the wireless transfer? Oh, the switch even here broadcasted it to everything, and these two didn't accept it. Did the access point lose anything? Actually, access point took nothing. Was any MAC or IP address lost during the wireless transfer? Nothing was lost during the transfer. Okay. What was the highest OSI layer the hub and access point used? Highest layer. OSI layer. In this case, it was the physical. If we look at the multiple layers of the OSI, it controls hardware devices, media, up the network. Best path through network. So basically in the network access, or the data link or network, describes ways of exchanging data frames over a common media and provides service to exchange individual pieces of data over the network between identified end devices. So in this case, it'd be the network layer would be the highest. These two devices used the network layer as the highest layer. Wait. What? What? No, okay. Alright. This is embarrassing. HIGHEST. Okay. Did the hub or access point ever replicate a PDU that was rejected with an X? Replicate, as in, I mean, so if I do this, replicate. What do you mean? Was a hub or access point ever replicate a PDU that was rejected? I guess not. No. It was simply ignored. When examining the PDU details, which MAC address appeared first, the source or the destination? The destination MAC address appears first. What the fuck? Hold on. Okay, let's look at that. My Jeep may integrate it as pinged at 75% when I try to drag a PDF. Okay. That explains a lot. Why would they appear in this order? Is done this way too, so that devices in a network can devices can see and respond to having the right the same MAC address as the destination. Jesus Christ. Why the... Are you... What the... What was... Was there a pattern to the MAC addressing in this simulation? For what we can tell... Oh, it asks us to ping all this. Oh, no thanks. Wait, what? Destination math was the same until it reached the router. From the router, it searched for the system. So what we can say is that is there a pattern to the MAC addressing the simulation? The MAC address was always the same before reaching the router. From there, it found its way to its destination. Did the switches ever replicate a PDU that was rejected with the red X? No, none. Every time the PDU was sent between the 10 network and the 172, there was a point where the MAC address suddenly changed. Where did it occur? This occurred two hours. Okay. This occurred at the router. Which devices use MAC address starting with 00D0? The router, from what we can tell. Let's say we were to try those other pings. Let's try. It says ping this and ping its buddy on the side. Ping 10.10.10.3. Goes to the access point and sent to the switch. Can't find it. It goes back it repings itself over here and then finds itself there. Strange. At the access point, it doesn't. Wait. Shit. I have to do them all. So the first one. Did the hub lose? Did wires change? Did the hub or access point ever do? No. Hub or access point. So let's see. .172.16.31.3. Address is the router. Okay, one sec. One second. There's a question here. To what devices the other MAC addresses belong? Well, this one is the router, or is it the? That's the thing. I'm confused because it changes because of the router. So the destination becomes that, and then the destination becomes this, but the source becomes this number. But this number ultimately isn't the one for the switch. Unless the switch here is the same. other MAC addresses belong to the hosts. Did the sending and receiving IPv4 address switch in any of the PDUs? No. This address stayed the same. Wait. If you follow up the reply to a ping, sometimes called a pong, Jesus, do the sending and receiving IPv4 addresses switch? Okay, let's try that. So let's go here, and do ping 172.16.31.5. It ponged. Destination changed from the source once it reached there. So yes, once the ping was received, it responded with the destination IPv4 switched. What is the pattern to IPv4 addressing this simulation? If the data is received but not replied, it IP source and destination stay the same. If the data is replied with, whatever, okay, stays the same. Why do different IP networks need to be assigned to different ports of a router? So that, what do different IP networks PDUs and be sent between between networks? If this simulation was configured with IPv6 instead of IPv4, what would be different? Oh shit. He did mention this in class. Something about IPv6. I'll say that using IPv6 every host would have a unique IP. Okay. Let's go. Okay, cool. Well, that makes sense to me. Yes, save. Close, close, close. Okay, that was 4. Let's do, as that was assignment 3, now let's do assignment 4. Okay. Okay. Let's look at question here. Examine the ARP, examine the switch MAC address table, and examine the ARP process. Examine the ARP. Click 172.1631.2 and open a command prompt. Okay. Enter ARP -D. To clear the command. Okay. Enter simu mode. Done. Can I extend this? There. Cool. Enter simu mode and enter the command ping this. 2 PDUs will be generated. The ping command cannot complete the ICMP packet without knowing the MAC. So the computer sends an ARP broadcast frame to find MAC address of the destination. Indeed. So ping 172.16.31.3. Cool. Is this the ARP? Or is this the ARP? Oh. Destination source IP. While this one, destination address is FFFF and source is that. It doesn't know, so it tries to look for it. Cool. Alright. Capture 40. So it sends this to the switch. FFF, the switch knows that it's all F's, therefore it pings it to everyone and sees who this is. So it sees that this accepts it. It's sent back to the switch. Switch saves it, sends it back, and then tells the system to send the frame. The frame then gets it back to the system, and the system accepts it. pinging back to the host, this source that I got it. Cool beans. That makes sense. How many copies of the PDU switch? Oh, shit. Click capture. The ARP PDU moves switch 1 while the CPU disappears. Waiting for ARP reply. 1. Open the PDU and record the destination MAC address. Is this address listed in the table above? Shit, I gotta do it again. Back to the beginning. What does it say? CPU. 2 okay, click capture. Capture. The ARP PDU moves. Switch 1 while the ICMP disappears, waiting for the ARP reply. Open the PDU and record the destination MAC. Quad Fs. That's in the table above. This MAC address is not listed in the table. Click for the PDU to the next device. How many copies of the PDU did switch 1 make? This switch made 3 copies of the PDU. No, not PSU, PDU. What is the IP address of the device that accepted the PDU? 172.16.31.3. Open the PDU and examine layer 2. What happened to the source and destination MAC? The source and destination MAC are now recorded, but the once destination MAC became the source. Click capture forward until PDU. How many copies of PDU did the switch make? Just 1. This time, it only made 1. Examine the ARP. Note that the ICMP packet reappears. Open the PDU and examine the MAC addresses. Do the MAC addresses of the source and destination align with the IP addresses? Note the ICMP packet reappears. Open the Padu and examine the Mac. Do the MAC addresses of the source align with their IP addresses? Where the fuck would I see that? Yes. Question mark? Yes. Switch back to real time. And ping completes. Click and enter an ARP-A. ARP-A. To what IP address does the MAC address entry correspond? The MAC address corresponds to the once destination MAC of host with IP 172.16.31.3. In general, when does an end device issue an ARP request? A device will issue an ARP request when it does not know the destination MAC address. Good beans. Examine the switch MAC address table. Generate additional traffic to populate the switch. From that, ping this. Cool beans. Click and open command prompt. How many replies were sent and received? Enter ping that. .10.10.10.3. For both, I would assume. For both. Yep. Examine the MAC address table and the switches. Click switch 1 and the CLI tab. Show MAC address table gig fast Ethernet gigabit. Do the entries correspond to those on the table above? We need a 0002. Yep, that's the fourth one. 000C, which is what I pinged from. So basically, from this system, I pinged to this, told it find this. it found this, saved it in its table while saving this one. If not already saved. Then 060, 70, 36 is also saved, I guess. E. Yep, it saves them all, even the routers, because it sent an ARP to each one and saved each one. Huh. Yes, each Mac. Yes, the Mac of each device was saved onto the table. So click switch 0 and the CLI. In this case, this is only going to give me... Actually, can I do that? Fuck, whatever. Show Mac address table. So it found... Wait. Okay. 0001 is router 0. Right. 6060 is those two. Right. Okay. Yes. Yours. Every Mac. The network was saved onto the table. Why are two MAC addresses associated with one port? Where does it say this? Oh, here? Only one. This is the case because that one port is connected to the access point. Finally, part 3. Click 31.2. Oh. CLR. CLS. Clear. No. CL. I don't know. Ping 10.10.10.1. Very good. Type ARP-A. What is the IP address of the new ARP table entry? ARP-A. Type ARP-A. What is the IP address of the new ARP table entry? What was it before? Hold on, let me clear it. Arp t ping then arp. Address of the new ARP. $192. Oh shit. Well, I guess basically these two. 172.16.31.3. And about 4. Okay. Clear it. Exit. Let's go to Simu. Repeat the ping. I'm gonna put up here. So denies it in 2 here, but accepts it over here. So there's 1, 2, 3. Sent back to the switch. Sent back to the host. ICMP is sent. Then goes over to WAN. Switch it back. Tells it that it's over here. It says, yep, it's good. That's a lot. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. There were a total of 16 PDUs. Jesus. 16 or 3? Just the ARPs, which is then sent to each. Click capture forward, click the PDU, and now switch 1. Oh, it's not done. This is gonna happen. Okay. Let's try that again. Wait, how many PDUs appear? Just 1. There it was. here, what is this? Target destination when it's at the switch. Target destination IP. Of the ARP request. Did I mess this up somehow? Shit. Yeah, let's try it again, I guess. Click 172.16.31.2 and ping them. Okay. Then type arp-a. Okay. Close. Switch to this. Repeat ping to 10.10.10.1. Whoa. There's two now. There's an ARP. R2. Click the PDU that is now at switch 0. Oh. Target IP. Aha. What is the target destination IP for this ARP request? 172. Target IP is this. For some reason. Destination IP address is not 10.10.10.1. Why? This is so because the IP 10.10.10.1 does not exist within that network. Housing. Same. Host 172.16.31.2. Gemini ARP on router 1. Switch to real time. Click router 1 and the clue type. Whoa. Interesting. And then show, so privilege executive, we gotta write enable. And then show MAC address table. How many MAC addresses are in a table and why? Oh, should I? Fuck, was I supposed to? Show ARP. Yes. Oh, wait, why did I create a table? There are none. This table. Because not actually sure. This let's go back here and ping. Oh, shit. ARP. The fuck? Why are there two? ICMP and an ARP? Oh, every single one receives it. It sends them all again. Sends it back. Sends it back. Sends this. Are there three or two? Have to do this again, I guess. Show MAC address table. None. Show ARP. 30 minutes. What happens to the first ping? I don't know. What the fuck? Router 1? I guess. That's what I'm going to assume. But problem is okay, you know. No. I'm gonna reopen it again. It's a possibility that I fucked it somehow. So let's try it again. So step 1, click 172.16, desktop, run, do ping 10.10.10.1. Then write arp-a, there's only one, and then arp/d. Let's switch the simulation. There, ping again. There's 2. Click capture forward. And destination target IP becomes that. So the destination IP address is not 10.10. Why? The destination. From there, examine the ARP on router 1. So switch to real-time mode. Click router 1 in the CL tab. Enable. Show MAC address table. No, not an underscore. That address. Okay. Why is this empty? Show ARP. There's mine. What happens to the first ping in this situation where the router responds to the ARP request? The first ping is read received by the router and is sent back to the host. From there, it is into P request, which router 1 sends the request to router 0. Okay, cool. Save this. Cool beanus. Okay. Well, that was the packet tracer. Um. Uh. I have it. In fact, let's go find it. ISC, Zelix, downloads. Well, this one. There you go. That's for you. Okay. Well, apart from the extension to lab 5 that we have to deal with, shit, misspelled that. One new document for my teacher, integrated. What? Class 6 Verilog. Oh my god. As well as a new assignment. Alright, well, we have integrated stuff tomorrow. Oh well. Anyway, that was the packet work. That wasn't perfect by me and by any means, but basically that's the idea. I'm gonna look it over, correct any of my mistakes, and deal with it. So, alright, guys. Till next time.